Hi, welcome to LeetCode. So in this video I want to discuss LeetCode problem 1415. The kth lexicographical string of all happy strings of length n. So the problem statement is that a happy string is a string that consists of only of letters of the set A, B and C. So the string can contain only three characters A, B and C. So and another condition is that si not equal to the si plus 1. So the character that is present at the index I not equal to the character present at I plus 1, right? So for example, string ABC is a happy string. Why? So all the characters are within ABC, right? Next condition is that string character present at I not equal to the character I plus present at the I plus 1. So here actually so I have to check only the two consecutive character that actually equal or not, right? So first consecutive character is A and B, both are actually not equal, so this is okay. Next another consecutive two character is B and C, both are not equal, so this is also valid. So all consecutive number is character is different, so this is a happy string. Suppose another string, suppose A, B, C, D. Okay, this is actually a happy string. No, why? First condition actually not valid, because they mentioned that only A, B and C can present. Here actually D also present, right? So that's why this is not a happy string. Suppose there is another string A, B, C. First condition is true, that all character present here in this string is within A, B and C. Now next condition is that two consecutive characters should be different. So here consecutive characters are first is AA, then AB, then BC. These two is not equal, no, so this is false, both are actually equal. So one of this actually it is false, then actually this is not a happy string, so this is not a happy string. Got it? Now next we want to say that given two integers n and k, consider a list of all happy strings of length n sorted in lexicographical order. So we have to return the kth string of this list, or return empty string if there are less than k happy string of length n. Suppose for this example, n is equal to 1 and k is equal to 3. So that means I have to generate all happy strings of length 1, right? And then after generating all those happy strings, I have to return the third largest or third lexicographical string, happy string, right, out of that. So which what are those happy strings we can generate of length 1? First I can generate A, then B, then C. So I have already achieved length 1, right? So if I sort these three string, so this are already sorted A, B and C. Now return the third string. So this is first string, this is second, this is third. So it returns C here, right? You can see that the here answer is C. Got it? Suppose our answer is k is equal to here is 4 or 5, anything greater than 3. Then we can say that okay, this is already maximum number of strings I can generate 3, but you are wanting greater than 3, so I have to return empty string for that situation. Got it? It may be possible. Now here actually n, the length range is 10. So what is the brute force approach like for each so there will be maximum 10 position. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this actually first position actually have 3 option out of, because they actually I can actually place 3 character. 3 character means 1 character, but out of this 3 character I can choose 3 character A, B and C. So for each position actually I have 3 option. I can either set A or B or C for first position. Next again I can place A or B or C. So each position actually have 3 option. Now how many actually maximum position actually I can actually have 10, because n actually is 10. So what will be time to study for this? Like how many actually string actually I can generate for each position. Actually I have 3, so 3 into 3 into 3, 10 times, right? 10 times actually I can actually this actually this will be multiplied with 3, all will be multiplied with 3, because each like a suppose there actually n is equal to 2. So first I can actually place a, then I have placed in the first position I actually fixed this. First position I actually fixed a. Next position, in the second position, first I can choose A, then again I can choose B, then again I can actually choose C. Next, suppose first position I have changed B, then again actually I can place A here, second position, then again actually place B here, then BC. So next, first position I have choose C, then actually I can choose second position A, then first position actually I have choose C, next is B, next is first position is C, second position is C. So you can see that how many actually combination actually possible. First, when actually I have placed fixed A here, so I can generate 3 number. Next again I have fixed B here, then actually I also can generate 3 different string. So how many actually this will multiply 3 into 3, so total 9 actually I can generate 9 string, correct? So that's why the time here actually the number of string will be 3 to the power 10. So this will be ultimately 6 into 10 to the power 5. So this is actually less than 10 to the power 8. So actually in brute force approach we can actually generate all those string. Then actually we can actually check what is actually the place of the kth string, right? Kth happy string. So how actually I can generate of length n string? So I have to generate strings of length n. So I actually have a temporary string. Okay, initially it is empty. First I can actually this is okay, this string actually not length is not equal to n, so actually I can actually add new character here. So suppose first I choose A here, or I can choose B here, or I can choose C, right? Now our string, suppose n is equal to suppose 3. Okay, so here actually I have reached a length is equal to 1. So again actually I can actually choose I can actually place a new character. So suppose I actually have choose A, then actually I can choose AB, then actually I can choose AC. Similarly for this string, I can choose BA, then BB, then BC. Here actually I can choose CA, then CB, then CC. Now all those string here actually is length 2. Still I can actually add new character in this string because I have to reach length 3. So first for this string, what actually I will add AAA, then actually AAB, then AAC. Then for this string I actually add three different character ABA, then ABB, then ABC. In this I will follow all the string actually I will add whenever I will get this string. Okay, so I'll check that this actually already length is equal to n, so I will not actually add new character here in this string. Now this is already actually happy string because I am actually adding only A, B and C. So this is first condition, this actually always valid, that because I am adding only A or B or C, right? So there is no possibility to present any other character except A, B and C, right? So first condition always true. Now second condition, what I have to check, that whenever adding, suppose here actually, suppose for A here I am adding a new character here actually A. So I will check that this actually possible, I can actually add or not. What is the condition here? Like they also mentioned that the string, the character present at I should not be equal to the character present at I plus 1. So here actually I am trying to add A. So before that I will check that whatever the actually character present at the previous index, that is different or not. If it is equal, then actually I will not add this. Okay, I will go to the next option for B. Okay, this is current character I am trying to add actually is B. So I'll check that this previous character already actually I have in the current string, that actually different or not. Okay, this is different, so I can actually add this. So I can actually add this string. Okay, got it. Now I have actually satisfied all this condition, that first I have ensured that only A, B or C will be present. Next is whenever actually I am adding a new character into the string, so I'll check that the previous previous index, the previous character present at the previous index, that is different or not. If it is different, then actually I will only add this. Okay, else I will go to the next character. Actually, I can check that actually I can actually add or not. Right. So both are condition 1 and 2 actually. 2 and actually I have ensured that, right. Next, what I have to do? So I have generated all those strings. So all those happy string. Now I have to return kth lexicographical string, sorted string, right. Now I have to sort this all the string that actually I have generated happy string. Then actually I will return k minus 1 string. Now there can be two situations. One case is that there is the total number actually, suppose m strings actually I have, okay, but k is greater than m. So what I have to do? I have to return empty. If k greater than m, so total number of m actually happy string actually generated is m. If k greater than m, then actually I will return empty. Else return k minus 1 string. This is the happy string, right? Got it. Now one thing, do I need to sort this all those string? How actually I can actually handle those? Because sorting is also take in log n, and here actually is string sort, so it will take n log n. Then actually the string compare, so this will be again big of L, the length of the string, maximum string. So how actually ensure that this is all, whatever actually string we are generating, that is actually also sorted during generation. So suppose this is actually empty. Initially our string is empty. Now I can actually choose A, then actually I can choose B also, I can actually choose C also, right? In the first position. So if I explore, so A will be always A is lexicographically always smaller than B, and B is always lexicographically smaller than C. So if I somehow explore all the string, all the happy string starting with A, if I explore all the string and store that at first at the front, then actually I try to explore all the string that is starting with B, then actually it will be always the starting with A will be placed before the string that is starting with B. Then actually I will start to explore the string starting with C. Got it? This will be sorted. So if I actually do the DFS type, like DFS type means first I will start explore with A, then again A, then again A. So right, then actually I try to explore first, then A, B. Okay, then actually I will try to explore A, C in this way. So here actually I am ensuring that whatever the string is starting with A, that will come first before AB, starting with AB string. Got it? Then actually I am starting with AC. Got it? Then actually I will start to explore starting with BA, then BB, then BC in this way. Got it? So now go to actually code. The logic is clear. And if you like the experience, please like the video. And if you not yet subscribed, please subscribe the channel. And if any doubt, any suggestion, you can comment on that. So now go to actually code. So this is actually the main function get happy string. Actually get in the length of the happy string, and the k is the kth lexicographically happy string I have to return. So this is a vector of string result. So it's actually storing all those happy string in this vector. Okay. So I'm calling this helper function. So here actually int k and the empty string. Initially the empty string actually I will pass. So now what will do, if our result size or the number of happy string is less than k, that time I have to return empty. They mention that if there is less than k happy string of length n, then return empty string. Okay. Else actually I actually have one valid index, so I will return k minus 1 index string. Got it? Now here actually I am not sorting anything, because I have already during generation of this happy string actually I have actually ensure that this is actually sorted. Right now, this helper function 3 argument actually I'm passing the n, the length of the string, and the kth string actually I want kth happy string, and the string s, current string empty, initially actually empty. So I'll check that if our result vector size is already k. So because I'm interested in the all the lexicographically smaller string will come first, so that's why I will stop that. I will stop immediately that if our result size already reached k, I don't need to generate the next happy string, so I return from that position. If suppose I have not reached yet, so I have to check if whatever the current string actually I have, that actually is length n or not, right? If it is length n, then I have to stop here and store this current happy string. So I'll check that if the length is equal to n, so I'll store the current string into the result vector. So result vector is storing all those happy strings. Now I'll return from here because I can't actually add any new character here. So else if it is not equal less than n, so what I have to do, I can actually start with a or b or c. Any character actually I can choose out of these 3 character a or b or c. So if I try to add a in the current string, whatever the current string actually I have string s, so what I have to do, I have to ensure that first time ensuring that this all the character will be out of a, b or c. This I am ensuring. Now next condition is that the character present at this current index that should be different to the previous index, right? So I'm trying to add here suppose a. So I'll check that the previous index, the previous character is present, so that should be different. So if the current string is already 0, then actually this is the first character I am adding, so I can actually add without checking. If I already have any character, at least one character, that I have to check, then I have to check whatever the last character present. So last character, if that is different to the current character I am trying to add, then I can add this. So I'll add this and calling this helper function again. If is the helper function again, horizontal passing n will be constant, k also constant, n string s I am adding s plus c, the current character a. Right. So here actually you will see that first what I am doing, I am actually starting with character a. I am trying to explore all those string, happy string that is starting with a, then again a, then again a. This actually I am answering the sorted lexically sorted order. Here actually first trying to explore with started trajectory a, then I am starting with a. Then I am starting whatever actually character a is not possible because the characters should be different. Next I try to explore a b. Then actually I'll go to the depth of a b. So I'll go to a b a, then a b b. This is not possible, so I'll go to a b c in this way. Then actually after completion of this all the string that is starting with AB, I will go to the next string starting with AC. I will go to that. So this actually answering the lexicographical sorting order, right? Got it? So I have shared this code into the description box. Actually, I take this help, and thank you. I hope this is clear for you. Thank you.